Good morning, everyone. Everyone is doing well today. We're ready to get started. So as was indicated in the chat, we are in the end game now. So we're at the stage now where we're getting into chapter 19. And this is a chapter I called Rubik's Cube's Beginnings. But if you're interested in solving the cube, this is the end. I mean, Rubik's Cube Beginnings is the chapter where we actually learn how to solve the cube. So if learning how to solve the cube is only the beginning, what more could there be? There could be understanding what's possible and versus what's impossible to do on the cube. We've already investigated a little bit about what's impossible to do on the cube, but we'll actually be able to come up with a full characterization of the solvability criteria. So what is impossible to do? But that's not till chapter 20. And so really what we're focusing on here is just, can we solve the cube? And if so, how do we do it? So let's get into that now. Have your cubes with you. You can see I've got a bunch of mine behind me, so that if I'm demonstrating something and I mess up, I can quickly replace it with a fresh one and get going. But yeah, have your cube with you, and we're going to try to solve the cube today. The first few things I just want to mention is a bit about notation. Now, when we start to solve the cube, I just reminded myself, unrelated to the cube, but related to the course, is I wanted to share with you. So on Friday, one of your fellow students, Solomon, managed to share with me one of the updates he did to the applet. So this is live now. Oops, I'm going to reverse it the other way. So thanks, Solomon, for putting this together. If we go to the OvalTrack page, the very basic applet that I referred to, if you click on that applet, I've put there the updated one. And what Solomon has done is he's added a few nice things he said that he wanted when he was playing around with the app, and he just found it useful to have some things that he wanted. So right now, when you go through it and you do all your moves, sometimes you'll find yourself making a mistake, like you'll do an RR. Oh, I wanted to do an R inverse instead. And so you maybe do a couple of those, and now it's kind of messed up your sequence, in that if you're doing this as a setup move, you want to go back and you want to read it in reverse, but now you've got these redundant moves and you kind of want to avoid those. Other issues, of course, are we can run off the screen. So the update Solomon made was he put the sequence down below as the history, and he also made this really cool reduce repeats. So it'll go through and it will, anywhere it sees like an R or prime R, it'll reduce those repeats, or turn a couple of turntable moves in a row, it'll repeat those because they're inverses. So reduce repeats, there you go, shrinks it down to a nice short sequence. So thank you very much for sharing that with us, Solomon. Much appreciated. All right. So now, to get to the Rubik's Cube, just a few bits of notation that I think is worth introducing at this stage. The bits of notation are really related to slice moves. We've just been talking about quarter twists of a face. We haven't, I'm not totally off the screen. Quarter twists of a face. We haven't talked much about the slice moves, other than, had some homework assignment exercises that had you do stuff with the slice moves for commutators and the like. So I'm just reintroducing those slice moves here. Capital M to denote the slice move, just really meaning middle layer, so capital M. And with the middle layer, you can turn it one of two directions, clockwise or counterclockwise, but it all depends on how you're looking at the cube, whether it's clockwise or counterclockwise. So a move like this, where you turn it in this direction, I like to think of this as the middle slice layer rotating in the upwards direction. If you're looking at it from the right side, that's a clockwise rotation. So that's why it's denoted MR. So from the right face, this is clockwise. So it's not an inverse move, it's a clockwise move, so a regular move. But if you're viewing it from the left side, it would be a counterclockwise move. So from the left face, from viewing it from the left face, so M sub L, this is an inverse move. So two different notations for the same move, and similarly for the other slice moves. So those are just a way to talk about slice moves. And then we've got whole cube moves. So this is actually just taking the whole cube and rotating it, depending on which axes you're rotating it about. We will call it an R rotation or an L inverse rotation if we're staring at it from the right face and we're rotating about that RL axis, and similarly for the other ones. So this is just a way to capture in notation some of these whole cube movements we might want to use. In terms of facet notation, we can label the stickers and then the locations these stickers reside in this way. And the way these labelings are done is, if I'd say look at a corner or maybe an edge sticker right here. This is in the front face and the up face, this edge cubie. And so the sticker on the front face, we refer to that one first, so little f, and then it's on the cubie that also shares a face with the up face, so it's little f and then a little u, and the other sticker on the opposite side is little u, little f. Corners, the way we read them is, this is a sticker on the front upright corner cubie, and this sticker is on the front face. So it's an F, and then you just go around clockwise around the cubie, identifying the faces. So this is FUR, whereas this is the URF sticker and location, and this is the RFU sticker and location. So this is just another way, instead of having to refer to numbers, we can use these strings instead. And sometimes it's easier, because if I said, you know, I'm thinking of the sticker in the 35th position. You might think, oh, I need to refer to that diagram. What is the 35th position? What's the sticker labeled 35? Where is its position? Whereas using this this facet notation can be a little bit easier to recognize. The recording overlay is not showing over top of the. Oh, sorry, is showing. Yes, thank you. Anytime I move my mouse over it, yeah, my apologies. Anytime I move my mouse over it, the overlay comes up. So I'm going to try to avoid moving my mouse. So thanks for that. I know it gets annoying. Instead, I should use my pointer here. I'll use my laser pointer. That's much better. The other thing is we've got some impossible moves. We've already identified some things that are impossible to do on the cube. This is always good to do when you're investigating a puzzle, what's impossible to do. A couple of the ones we've proven already are, we've shown it's impossible to do a single edge flip. That's one we proved. How do we prove it? We ignored the labeling on the corner stickers and we just focused on the edge sticker labels. And then a basic move is an even permutation of the edge stickers. So if every basic move is an even permutation of the edge stickers, then we can only do even permutations of the edge stickers. And therefore, we can't do an edge flip. So we've proven that. We can't do an edge swap. We've proven that. Any basic move is an even permutation of the cubies of the Rubik's Cube. So we can't do that. We can't do a corner swap. Again, every move on a Rubik's Cube is an even permutation of the cubies. And so we can't do any odd permutation of the cubie. Can't swap two edges, can't swap two corners. The middle ones here, we have not proven these, aside from actually just getting Sage to verify these. We've had Sage verify that we can't rotate a single corner, or we can't rotate two corners in the same direction. Why these are impossible, we will prove this in chapter 20. This is essentially going beyond that. This chapter is about the basics of the Rubik Cube, so introduction or the beginnings. But later in chapter 20, we'll come out with a more thorough solution or solvability criteria, and that will capture these two impossible moves as well. Okay, so now let's focus on solvability, or how to solve. So I shouldn't say solvability, because it's not a question of whether it's solvable or not that we're going to be answering. We're going to assume that we're given a scrambled cube and we're going to try to solve it. I'm going to list here the useful moves that we're going to want to know. We've seen already in other puzzles, oval track, 15 puzzle, 3 cycles are golden. They're the golden ticket. We want to be able to do 3 cycles because they are even permutations, so we can generally get them with commutators. And so they're really the fundamental moves that we usually build on a puzzle because they are even and we can get them with commutators. We can't build a swap using commutators because commutators are always even. So 3 cycles are the best we can do, and we can actually build them on the Rubik's Cube. We've seen a couple of ways to build 3 cycles on assignments. So here's what I've called C1, C for corner, 1 for the first of however many 3 cycles I'm going to write down. So the basic corner 3 cycle is this one. It cycles 2 corners in the top or the up layer, and then 1 in the back right layer. We can do a conjugate of it and make it 3 cycle all things in the same layer. The conjugate is just do a back inverse move first to bring that back corner piece down to the bottom layer to then do the conjugation. So it would look something like, where did my cube twister go? It vanished. I'm going to have to open up a new one because I think it's being a little bit stubborn. So instead I'll go to my document canon. Where's my document? There it is. Okay, so this is saying we've got the ability to do a corner 3 cycle of these 3. So if I wanted to do a corner 3 cycle of this one and this one back here, the first thing I do is bring it down. And now I can corner 3 cycle these ones. So I'll do that corner 3 cycle move. Bring that left face down, slide that corner piece around and in place, bring it back up, and then take the commutator with the up move. Down, undo that down move, undo that move, and then undo the up move. So that's my commutator done, and then undo the setup move. And that gives us our corner 3 cycle. If we want to do the inverse of it, get them to rotate in the other direction. To do the inverse of a commutator, I just do the 2 moves in the commutator in reverse order. So to do the inverse, well, the first move I did was with the commutator was to bring this side, the left elevator down, slide this thing across, left elevator up, and then I did the commutator with the up move. If I'm going to do the inverse, I'll do the up move first, and then the second move, undo the up move, undo that second move. And that did the 3 cycle in the reverse order. And then I'll undo the setup move to bring it back up. So we've got the ability to 3 cycle these 3 pieces. Now I've written this move sequence down, C1 and C1 prime. C1 prime is just telling us we can 3 cycle things all on the same level. It was built from the C1. And the reason I've written these ones down is just because for practical purposes, we want to be able to 3 cycle to solve the cube. For theoretical purposes, we want to be able to 3 cycle pieces all on the same layer, or potentially 2 pieces on one layer and 1 on the other layer. So these are good to have theoretically. In practice, however, I'll show you the one I usually do. So this is the one I usually do in practice. I've listed it later on in the notes, but I usually say, okay, if I want to 3 cycle 3 pieces that are all on the same layer, I rotate the cube so now it's facing me, so now it's the front layer, and I do almost that same sequence, except instead of a D squared, I just do a D move. So that means I bring this down, so a left move, and then I just do a D. So instead of bringing this piece from back here all the way around into that spot, I only bring this one. So if I do that one and then send it up. So I just brought this piece here. If I do the commutator with the up move, it's just going to bring that piece there. And that's the only piece that's in the intersection of both moves. So what it means is I already know I've already done one of the 4 moves I need to do. I've done essentially the alpha. I still need to do beta, alpha inverse, beta inverse, but one of the 4 moves. My second move is going to be the beta move or U move. I already know it's going to only affect these 3 pieces. And so I'll do that up move and then L, D, L inverse, and then undo the up move. And so it affected these 2 and this one. And so those are all in the front face. But the nice thing is I can just now do a whole cube rotation and now they're all in the up face. So I've got a move that cycles 3 pieces all in the up face, which wasn't a conjugate of this C1 move. It was actually a little bit simpler. I just say I want to cycle these 3 things. Where do I want to go? Which piece do I want to go where? I want this one, blue, white, needs to come back here. This one needs to go blue. It's blue, yellow. It needs to go here. So I need that piece to go into that location. So I need them to cycle in this direction, counterclockwise. And so I just rotate the puzzle. So now they're facing me. They're on the front face. And then I just do the commutator. It's a question of whether I do the U move first or that sort of elevator move first. And it all depends on where I want this piece to go as to which direction I want to go. And you just get some experience. Maybe you do it twice if you don't care about which direction you want to go. You do it once and see, did it work? Nope, I'm still 1 away. Do it again, because you can square it and get the 3 cycle in the opposite direction. But for me, I just like to say, okay, this needs to go there. So I'll do the up move first, because now when I do the elevator move, it puts it into the right spot. So I've done the elevator move, up inverse, and then undo that elevator move. And that does the 3 cycle all on the same layer. So that's just one thing we can do with the kind of move sequences I've listed here, is we can make some small changes. And all I really did was change that D squared. I changed just this D squared. I wanted my pointer. There we go. It's not my pointer. This is my pointer. I changed that D squared to just a D, and that then affected this front corner piece. We got some corner twisting moves, which we've learned about already. We use one of the elevators, the left elevator, to bring it down, the front elevator to bring it up, and it comes up twisted, and then you do the commutator with the U face. So all of these are basically commutators with a U move. We got our edge moves. These are nice ones to do, because for an edge move, we just do the middle slice move and an up squared. So I take middle slice, up squared, middle slice in the opposite direction. And because an up squared is its own inverse, I can just do the up squared again. And that cycled 3 around the belt. So I can do it again. One more time, should bring them home. So we've got a way to 3 cycle things along the belt. What if I wanted to 3 cycle things that weren't along the belt? Well, what I'll do is I'll bring the edge piece down using a conjugate. So I bring it from here down to here. Now those 3 are along the belt, so I can cycle them. And then undo that setup move. And now I've got a way to cycle 3 along the belt. Again, I'll do it again. It cycled them 1 more time, and last time, cycle them 1 more time. And we've got a way now to cycle 3 on the same layer. And so that is that this E1 prime. And then we've got the edge flipping moves. This is essentially the longest move. The edge flipping move is probably the longest move we have. Why is it longer than the corner rotating move? Well, with the corner rotating move, we were able to bring the piece down with 1 elevator. And then, oops, I'll do it up here. We were able to bring a piece down with 1 elevator. So maybe like this piece up here comes down with 1 elevator. And then we could get it off of that elevator, and then we pick it up with the front elevator, maybe this direction. So we've got a left elevator and a front elevator that we can use to bring it down and bring it back up. But with these edge pieces, I can't bring it up with any other elevator other than the slice that I'm turning it on. There we are, slice that I'm turning it on. So I had to be a little bit more, or we have to be a little bit more creative with those. So let's see how that move works. So we're just reviewing these things that we've seen before. So what I want to do is I want to flip this edge piece, and I don't want anything else in the up layer to get affected. So I bring it down with a slice, and it's right here. I get it off of that slice, and then I restore that slice. So I basically brought it down, moved it off, and restored it. So now all of these pieces, except for that one edge, has been left where it's supposed to be. It's been unchanged. The problem is if I I now want to pick this piece up and bring it back up there. The problem is if I just bring that middle slice down and slide it into place, well, I'm just undoing the move I used to get it out of the way in the first place. So what I'm going to do is I am going to do what I never recommend anyone do, is to stand under the elevator before it comes down. So we slide it into place. Now the elevator is going to come down, and I like to think about this as squishing it. Now I bring that elevator down, it squishes that one by sending it to the back. The nice thing about standing under the elevator when it comes down and getting squished in that way is when I spin it all the way around, it's now flipped. Right? Red was there, but now red's on the back side. So now I spin it into place and send it back up, and I've got a way to flip it. The idea was I just wanted a way to flip that one edge. I don't care what happens to the rest of the cube. Well, I care about what happens to the rest of the top layer because I want to do a commutator with the up move. So I don't want any of these to get affected, just that one edge piece. So I bring it downstairs, I fiddle around with it downstairs, try to get it to flip in some way and bring it back up. So now it's flipped. This is the longest sequence I pretty much just have to remember is how I flip this one, because I'm going to have to undo it. And so now I rotate the up layer. This is a commutator. I bring a new piece into that position. And now I undo the sequence I used to flip that piece. So I brought it down. Now, instead of hiding it on the side, I've got to do the last thing I did, which was move it around back. So I move it around back, and then I unsquish it. Bring the elevator up, that sucks it across. So that was basically being under the elevator as it goes up. Hide it in the side, bring the elevator down again, slide it into place, bring it up, and now it's unflipped that one. And it restored the bottom because we've effectively done a commutator here. So then I undo the up. And so I got this edge flipping move that does these two. So we can do it again, just it's order 2. So bring it down, hide it in the side, elevator up, slide it across, squish it, bring it all the way around. Now it's fixed. Slide this across, undo the move sequence. Bring it down, hide it in the back, unsquish it, hide it in the side, bring the elevator down, load it up, send it home, undo the up move. And there we go. So we've got a way, using commutators to flip edges. Now you may learn other methods. There's other methods for flipping. You can do things like, if I just do middle slice up, and I do that 4 times. Middle slice, up, middle slice, up, middle slice, up. So I've done a MU move 4 times. MU, 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 MU. And now I do the reverse. UM, UM, not the reverse in terms of their inverses, just reverse the order. Now I do a UM, 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 UM. Then I got a way to flip 2 opposite each other. So there are other ways to do flips. It's just that MU, 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 UM, 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 UM is not a commutator. So it's not really clear how one would have built that to begin with. Maybe computer exploration and the like. But our goal is we want to be able to justify where these moves are coming from. So we can build this edge flipping move using 3 cycles, and we can transfer those ideas to other puzzles. This MU 4 times and then UM 4 times. It works on this puzzle, but it might not carry over to any other puzzle. Okay, so that's all the moves now we need on the Rubik's Cube. And so now we can go ahead and go for our strategy. Our strategy is to complete the solve in this way. Solve the cross, solve the top. And by solve the cross, I mean a deep cross. So we want to match up the edge color with the one in the middle. So see how the other side of the edge, the yellow is matching the center. So it's a deep cross. And then we go in and complete the corners as step 2 in the first layer. And then we complete the middle layer for step 3. And then we flip the puzzle over, complete the corners for step 4, and complete the edges for step 5. It's only at really this point we're going to need these special moves. Just like on the oval track puzzle and the like, it's really when you get to the end game that you need the special moves. We will find them useful in step 3 as well, setting those layers into place. Okay, so setting those middle edge pieces into place. I've got a couple of listed here, but the idea is now we're just going to go ahead and we're going to play around with the cube and try to solve it. So I encourage you to feel free to mess your cube up. You just scramble it in any way you can. And then we'll go for a solve on it. I haven't scrambled yours before. Feel free to do so now. Okay, so we've got our scrambled cube. Now what we want to do is we want to go ahead and go for the solve. The first step is pick a color. Pick a color, and that's what we're going to call our top layer, and we're going to solve it. Okay, so Eric's voting for red, so let's go ahead and vote for red, or do a red solve. So I look for the red center. There's the red center. And what I want to do is now build everything up around it. One thing to keep in mind is that red is always opposite orange, if you haven't noticed this already. So red is always opposite orange, green is always opposite blue, and yellow is always opposite white. I shouldn't say it's always opposite. On my cube, it's always opposite. There's no way to change these relationships. But depending on how you stickered your cube or how it came from the manufacturer, they might use a different coloring pattern, but this is a pretty standard one. The other thing is, if you hold it so blue's up top and red's on the front, then you already know that the back is orange, because that's opposite red. The bottom is green. So then it's just white and yellow that we have to decide where it goes. And this part of the coloring scheme is generally pretty standard as well, is that blue up top, red in the front, yellow is going to be on that side. And I turn it, and there it is. So knowing your coloring scheme is quite helpful, because now when I look at this red, I see that I've got a red blue. It actually is already in place, but I'm not too worried about that. It's already in place. I just need to know that, okay, if that's the red blue, then the sticker that, or the edge piece that's going to be here has got to be the red green. So I need a red green. So I search around. Well, I found a red white, so I might as well deal with that. So what I'll do is I want that red white to land up here. So in order to get it up there, what I can do is I just play around with it. I just move it around, making sure I don't mess up anything that's already set. So I'll rotate the front face. That lines up the whites. Then I'll rotate this face. And I've solved now the red, white. The red, blue is also solved. And I scan around. It's good to hold on to the cube. Maybe put a finger on the up face so that as you move it around, you know how to rotate back to where you were looking at it. So there's a red, yellow. Oh, that one works out quite nicely because the yellows are already matched up. So then I can rotate it and it lands up top. So that one's solved. So we've got the yellows, the blues, the whites. Now I just need to put the red, green into place. Now I'm not using any special moves here. I'm just sort of going around saying, okay, well, at this point, I see there's my red, green. I need it to go up here. The problem is if I use that face, it's rotated up there, flipped. So what I do for this one is I just keep it down here. And what I can do is I can avoid messing up this piece by doing the following. I'll take that red, white piece. I'll just get it off and out of the way temporarily. So I'll get it out of the way. That's like a beta move. Then I'll take this piece and I'll rotate it next to that white face. And the reason, sorry, we'll do it this way. Actually, let me reset that. I'll take this piece because I want the green to match that green. I'll move it over so that it's underneath this piece with the red, white one. And I want to just slide it across so that the greens match and then send it home. And when I did this, bring it up to get those edge matches, I have to remember that I moved this piece out of the way. So then I slide it home and then I bring that edge piece back. So just a little bit of play, you know, trial and error. It's no special moves are happening here. I'm just doing the best I can. and I got the deep cross now. Now that we've got that deep cross, we're going to go for the corners. So I just scan around and see if I can find, I usually keep my finger on the top, try to find any red pieces. Oh, there's a red piece, red, green, white. That corner piece, red, green, white, has got to go all the way over here. So I'll spin it around just so I can see it's visible. Red, green, white, it's got to go up here. I need the red to go up top. So in this case, right now that green is on top. So I need a move that brings that green down and then allows me to slide that red into its place. So if I bring it down like this, then I see the green sticker lands there. That's precisely where my red sticker is. So I'll get it out of the way, bring that corner piece down, load it in, send it up. So just like elevators again. Let's go around. Oh, we've got, where's another red corner? Oh, there's a red corner down here. So it's in the bottom layer. It's a yellow, green, red. So I scan around, where's the yellow, green? Oh, it's actually underneath where it's supposed to go. So that's fine. If it was anywhere else, I would just spin it till it's underneath where it's supposed to go. Now it's underneath where it's supposed to go. That red sticker, I'd like it to be on one of these sides. The reason is because the only way I'm going to get it into this position with the red on top is I either need the red sticker here, so that when I bring it up, it lands on top, or I need the red sticker over here, so that when it lands with that blue sticker and I rotate this, it comes up top. Right now, the red sticker is on the bottom. So that's a bit of a problem, but not to worry. We do the kinds of same idea that we did with the flipping the edge. We squish it. We have an elevator. It's sitting underneath it. We squish it. So I bring the elevator down and I squish it. That moved the red sticker onto the side. So then I'll just bring it back so it's visible. Now it's here. I'll undo that elevator move. That brings it back up. I'll slide it into place. Now I've got the red sticker on the side. That means when this blue comes down, I'm going to load it in with that elevator. So I get it off of that elevator, bring that one down, load it into place, send it up. And that's got that corner solved. And we keep going around. This one, the corner sticker is already, or the corner is already up there. It just needs to be rotated. I'm not going to do a special rotation move. There's no need to do extra effort here. We can just do general heuristics here, just play around with it. So I need to get it out of there, bring it down using an elevator. I've really got two choices of elevators to bring it down with. I'm going to choose the elevator that keeps the sticker on the side. The red sticker, I want to stay on the side. So I'll choose this elevator to bring it down, get it off of that elevator, load that elevator back up, slide it underneath. I want to bring that up here. I notice that the red sticker's on this side, so I need that orange sticker to come down to the red to replace it. So I get the red sticker out of the way, bring this down, load it into the elevator, send it up. And we move around to the next one. Red sticker on the side, bring it down so it's still on the side, get it out of the way, elevator up, put it underneath. I need that red sticker to go where the green one is, get it out of the way, elevator down, load it in place, send it back up. And so now we've got our top layer solved. It's at this point we need to do the middle layer, these four around the belt. But the problem is we've done so much work to get the top layer done that we don't want to mess up that work. So this is where we're going to need to be a little bit more careful. This is where I have these couple of move sequences that will allow us to insert pieces. So this one here says, if you want to insert this edge piece into the belt, decide whether you want to go right or left. In other words, is it a red, yellow, in which case you go right, or is it a red, white, in which case you'd go left? And depending on which way you want to go, you use this product of two commutators. These were the Z commutators that we introduced when in the commutator section. These are the thing master called the Z commutators. So we can use a product of Z commutators to insert these things in place. And that's perfectly reasonable way to go, using a couple of commutators in this way. Or this is the way I like to do it, is I like to use the fact that we have a 3-cycle with that middle slice layer, this 3-cycle up here, which is a good one to have. So this E1 move, that edge 3 cycle. That's a good one. That's only cycles things around the belt, which is a bit of an issue, but it's a good one to know nonetheless, because we can use it here in the following way. So here's how I'm going to use this 3 cycle. So I'm going to turn the puzzle. The nice thing about this way is it allows me to turn the puzzle upside down. So I take the puzzle, I flip it upside down, and at this point, I scan across and I say, okay, I want a green-white piece. Oh, there it is. There's the green-white piece. So that's the piece I want to go here. What I do is I just move it so that it's matched against the opposite colored center. And so I need that piece to go this way. So I need that piece to land there. What I can do is I can 3 cycle things. I can send that piece down here, this piece back here, and this piece here. That's my 3 cycle. If I do the middle slice and then double tap the up layer. So if I've got a move that sends that piece here, then let me set it up by moving this piece down to that position. So this is my setup move for a conjugate. Move it down here. Now it's in a prime position to receive that edge piece. So we go ahead and do our 3 cycle. Double tap, middle slice down, double tap. That did the 3 cycle around the belt. And now I undo my setup move, which brought the piece down here. So I'll undo it and I'll send it up. And that fixed that edge piece. So then we just scan around. Where's another edge piece? The edge pieces, because orange is the top layer, the edge pieces are going to be those pieces without orange on them. So I can find one here. There's a blue-yellow one. It's got to go into that position. So I match it opposite the color in the center. Bring this piece underneath. So setup move, 3 cycle, undo setup move. That edge piece is fixed. Keep scanning around. There's a orange. Oh, orange is in that layer, so I don't want to touch that one. There's an orange piece. I'm not going to touch that one. Oh, here's a blue-white. Blue-white needs to go there. So I'll match the centerpiece. And so if I need it to go this side, my setup move is going to bring that piece over to here. So I setup move. So now that piece is landing here. Do my 3 cycle. Middle slice, double tap, middle slice, double tap. Undo my setup move. And that has moved that piece there. And we've got one more edge piece to fix. There it is, yellow, green. I match this edge color to the opposite color for the center. So that's that one. I need it to go this way. So I'll bring that piece over, do my edge 3 cycle, and then undo the setup move. And now we finished our middle layer. So our middle layer is all done. And now we're going to attack the top layer. At this stage for the top layer, there's 4 corners. They could be permuted in 4 factorial ways. So what we end up doing is just bring one home and see what happens. So I just rotate, I'll pick one, maybe the white blue one. So I'll find the white blue, rotate it home. There it is, white blue. And I look at the remaining 3. This one's in the right spot as well, because it's a green, white, and that one's got green and white on it. So that's in the right spot. Oh, these 2 need to be swapped. Okay, so these 2 need to be swapped. That's a problem. I don't know how to swap 2 corner pieces, but that just means that if those 2 need to be swapped, then if I rotate the top and put one of those ones home, then none of the other pieces are in their right position, which means they need to be 3 cycled. So now I've got a spot where I just need to do a 3 cycle. So that's the thing, is to observe that if you've got an odd permutation at the end, just do a twist of the face. Now you got an even one, so you can use 3 cycles. So that one's in the right spot. These 3 need to get cycled around. We can use one of our 3 cycling edge moves, or sorry, corner moves. I look at where this one needs to go. That's a blue, orange, yellow. It needs to go blue, orange, yellow right here. So that piece needs to go here. This piece needs to go here. This piece needs to go here. So I need to do a cycle in this direction. And so I can do that using our 3 cycling moves. So we're in the last layer here. I'll just indicate that what we're doing is a move like this, permuting the corners. And so there's our move sequence for permuting the corners. So I'll bring this one down, slide it into place. That's the first move, commutator with the up move, and then undo the up move. And so I've 3-cycled the corners. Now I look and are they in the right spot? This needs to be a blue, orange, yellow. That's blue, orange, yellow. Yeah. That needs to be a blue, white, orange. That's a blue, white, orange, and so on around the puzzle. All of these are in the right spots. They're just not in the proper orientation. So now we can go ahead and properly orient them by rotating them. I need the orange faces to be up top. So I pick 2 corner pieces. This one needs to get rotated clockwise, but so does this one, and so does this one. So I need to rotate 3 of them clockwise. I only have a move that rotates 2 of them in opposite directions. And that's fine because I could do 2 in opposite directions and then do another 2 in opposite directions, which will have the equivalent of rotating all 3 in the same direction. So let's go ahead and do that. We are going to rotate this one so that the orange comes up top, and then we'll do the opposite to this one. Now, there's some choices there. Which direction do you want to make these things rotate? The way I think about it is if I want the orange to come up top, I need to keep the orange on the side when I do the elevator moves. So my first elevator move is going to be with this piece on the left side. Get it out of the way, bring that up, pick it up with the front elevator. So that fixed that one. And now I do the commutator with the up move. So I brought that across, and now I do the opposite front face, pick it up with the left face, and then undo the up move. And so that rotated this one, and it rotated this in the opposite direction. So now it needs to be rotated counterclockwise to get home, whereas this one needs to be rotated clockwise to get home. So I'm in good shape because these need to be rotated opposite directions. So I take this piece and I say orange is on the side, I want it up top, so I'll keep it on the side. I need to bring it down with one elevator, pick it up with the other. So I'll bring it down with the elevator that sticker's on the side of, hide it in the back, pick it up with the other elevator, send it up. Then undo that move sequence, just remembering which face I turned last. I brought it up last with the left elevator, so that's the first elevator I use because I'm doing a commutator. Hide it, bring the front elevator down, pick it up, send it up, and undo the up move. And now all my corners are fixed. So I'm systematically going through permuting them using 3 cycles, twisting them using these twisting pairs. And now we've got our edges to deal with. Oh, our edges are all in the right spot. Well, that's no fun. Let's pretend our edges weren't all in the right spot. Maybe something like, okay, there we go. So suppose we got something like this and our edges aren't in the right spot. So I have to decide, where do I want, are any edges in the right spot? No, they aren't. So I'm going to come up with a move sequence that at least puts one edge in the right spot. So we are at this stage now. Permute the edges. And I just like to remember this as my nice slice move that permutes the edges. What does it do? It takes this piece that's sitting in the up front and it drops it down to the one below. And then the rest just sort of follows. So it's that 3 cycle. So I just need to decide, do I want the piece in the front up position to drop down or not? So what I'll do is I'll think, maybe I'll involve these 3 in the 3 cycles. So I'll bring this piece, which needs to be an orange blue piece. I'll bring it down here. So this, sorry, let me see, not orange. Yeah, orange blue. That needs to be an orange blue piece. Okay, so when I bring it down here, I want the orange blue piece to drop into that position. Okay, that's good shape. I can do my 3 cycle. I've done the 3 cycle, undo the setup move. Now it's in the right location. And then I just keep scanning around. There's going to be 3 left to do. They're going to need to be 3 cycled if they're not in the right spot, because it's got to be an even permutation at this point. I need this piece to go back there. So I don't need it to drop forward. I need it to go back. So I need this to go in the opposite direction, which means I just need to do the inverse of the 3 cycle. the inverse of my commutator, normally I hit the middle slice and then the up layer second. To do the inverse, I do the up move first and the middle slice second. And that's just because the commutator of the inverse of a commutator is just the commutator in the reverse order. And so there we go. We've cycled them around and we've just got an edge flip to deal with now. Double edge flip. So I want to flip this edge first. I use my long edge sequence, hide it in the side, bring that up underneath, squish it, bring it around, bring it up. That's the flipping that one. Commutator with the up move. Now unflip, bring it down, hide it in the back, unsquish it, hide it in the side, elevator down, load it up, send it home, and bring it across. And so now we've got our puzzle solved. And the thing to keep in mind with the way we solved the puzzle was we only had 4 special kinds of moves: edge 3 cycling, corner 3 cycling, edge flipping in pairs, corner twisting in pairs. Those were the only 4 moves we needed. And each one of those moves we built using commutators. So commutators to build those 4 moves are really all we need. There's really a theoretical question here though, is are those 4 moves really enough? Can you get into a situation where you need something more than those 4 moves? That's what chapter 20 is about. Chapter 20 is about, no, these 4 moves are enough. Chapter 19 is about using these 4 moves to actually solve the puzzle. So that's it. We'll call up, is M move the same? Good question. So is an M move like that? Where are we here? I'm not even on the screen. There we are. Is an M move the same as an, in this case, an LR inverse? So this is our M move. An L would go like this, and an R inverse would go like this. So if we look at the difference here, an M move has the 2 orange bands sandwiching the blue one with the blue on the up face. Whereas an LR inverse has the 2 orange bands sandwiching the blue face, but now blue is in the front. So M is not necessarily the same as this, but if we do an L R inverse and then a whole cube rotation, that's the same as the M move. So an L R inverse and then a cube rotation in the clockwise direction about the right face. So an L R inverse and then that scripty R move. That's the same as an M move. So there's a whole cube rotation in there. Yeah. So good idea for that. All right, I'm going to stop the recording here, but I'm happy to stick around as usual. We can chat about questions and whatnot. Just can't find the stop record button. It's hidden here somewhere. There it is. It's behind me.